Hello and welcome to the DIY build instruction video for the 1201 Bandpass filters. Today I'm going to show you how to do it, so don't worry if you've never done a project like this before. It's quite a good one to learn how to do soldering and stuff. If you want to see the demo to this, there's a link up here and in the description. This is available as a partial kit, which means that you'll need to source the common components like the resistors and capacitors yourself, but that is the cheapest way to get your hands on one of these things, making it yourself. And I'm kind of actively encouraging you to build up a stock of parts so that you can start getting into synth electronics and maybe even start building up your own circuits. This should be a really fun build, and I hope that it's going to make you want to do more stuff and get involved in the synth builders community. So first step, I'm going to go through all of the components and demystify that if you've not done that before. But if you want to skip that section and go straight to the start of the build, you can check the timestamps in the bar down here and go straight to that. So if you've not done this already, what you want to do is go to the module documents, which can be accessed by the shop page, and open up the build guide, which we're going to be referring to through the build. The first page shows you the different boards that we're going to be working with, and the second page has the bill of materials. These are all of the components that we're going to be soldering onto our printed circuit boards. The components highlighted in grey here at the top are included with the partial kit. Let's go through those. You have 3 of these green LEDs, 4 light dependent resistors, 3 of these single row female headers, 1 11mm female to female standoff, and 2 M2 screws to go with it, a slide switch like this, and 2 potentiometer knobs. The rest of these components you're going to have to source yourself, so let's go through them. I'll tell you exactly which ones to get and some tips for buying them. The first type of component that we're going to be looking at are resistors. These are 1/4 watt 1% metal film resistors. 1/4 watt means they can handle 1/4 of a watt in power. 1% means they have a tolerance of 1% of their stated value. So if it's 100k, it's going to be within 99k to 101k, 1% either way of the stated value. And they're made from metal film. If you want to use carbon resistors, they'll work fine too. On the bill of materials, if you look at the resistors, you have a reference here which is on the silk screen. You see those R numbers, R12, R3. That tells you which resistors it's referring to on the silk screen of the PCB, so you can find them in the bill of materials. But they all also have their value written there too, so you can't mess it up unless you really try. On the values of the resistors, they're all measured in ohms. There's kilo ohms marked with a K, so that is 1000 ohms, so this is 22,000 ohms. The K there is acting as a decimal place, so this is 2.2 thousand ohms. The reason you put the K there on the silk screen instead of a decimal place is because it's very easy to get confused on these tiny silk screens and think that a 2.2k is a 22k. This makes it a lot clearer. You'll also see that we have a 680R here. That just means 680 ohms. The R means ohms, singular ohms, instead of thousands of ohms. Resistors are really cheap, and so I would recommend that you buy them in batches of 100, so then you've got loads of them to do other projects with as well. And buying them in bigger numbers, of course, means that you'll get more of a discount for them individually. You can get these from places just like eBay. You don't have to get fancy ones. Next down the list on the bill of materials, we have these alpha 9mm vertical potentiometers. These things, these variable resistors, and they are B100K dual gang T18 shaft. So let me explain what that means. The B means that the potentiometer has a linear taper. The 100K is pretty self-explanatory. It's just the resistance of it. You can see it written on that there. Dual gang means that it actually has 2 potentiometers in here, in essence, totally separated from each other, 2 wipers and 2 resistive tracks. That's why it's got 2 sets of 3 legs coming out of there, and both of those wipers inside here are moved in unison by this one shaft, and the shaft, you'll see, has these splines on it. That is the T18 type, and that will fit with our knobs. You can buy these from places like Thonk. Make sure that you have the washers and nuts for these as well. Next on the list are the capacitors. There's a few different types of capacitor that we're going to be using. All of the capacitors as well have reference numbers. These begin with C, whereas the resistors began with R. You can see one at the top here. See there? C3. Capacitance is measured in farads, but a farad is actually really big. So most of the values that you'll be seeing are nanofarads or picofarads, which are much smaller. So the P here stands for picofarad and the N is for nanofarad. And just like before, we've put the P in the place of a decimal place to avoid confusion. First off, let's look at these ceramic capacitors. These are the type of ceramic capacitor that I like to use. They are multi-layer ceramic capacitors. Slightly better in some ways that are boring to explain than just your usual ceramic capacitors that you might see that look more like this, but this type will do the job just fine as well. Mostly I just think that these look nicer, so they're worth getting. You'll see that they have codes written on them, and I've also put the codes here in brackets next to the value so you can easily identify them. I've labelled the 104 ceramic capacitors as 100 NF, but they are equivalent to 0.1 UF, so you may want to search for that value as well. So that's the ceramic capacitors. The next type is the polyester box capacitor. They look like this, slightly more expensive, but you need to use this type. It won't work as well if you use ceramics in the place of these. This is the third type of capacitor that we're going to be using. This is an electrolytic capacitor, and you see that the leads come only out of one end of the electrolytic capacitor. That's why they are called radial electrolytic capacitors, and these capacitors are polarized. That means that they need to go in the right way round. Unlike the other type of capacitors that we have, it doesn't matter which way those go round, these ones have to go in the right way round. You can tell which side is which because one side has a negative stripe on it, and that negative lead is slightly shorter than the positive one. It's important that the electrolytic capacitors do not have a height more than 10 millimeters, otherwise they won't fit between the PCBs. The 1 microfarad and the 10 microfarad can be rated for 16 volts or above, not below 16 volts, and the 22 microfarads should be rated for 25 volts or above. Okay, so the next type of component also has to go in the right way round. These are diodes. These ones specifically are 1N4148 signal diodes, often look like this in an orangey colour, and you see that on one side there is a black stripe. That is the cathode, the negative terminal on it, and that black stripe needs to match up with the stripe on the silk screen. They have to be pointing the same direction towards the circular pad. This type of diode, the 1N4148s, are really commonly used in synth electronics, so I'd advise buying a few of these. These ones are a little less used, but I find them very useful. These are Schottky diodes, and you do need to use this type as opposed to this type in their specific application within this module. There are a couple of integrated circuits that we're going to be using in this module. These are both op amps, the TLO72 and the TLO74. The difference, as you can tell from the names, is that the smaller one has 2 op amps in it and the bigger package has 4. Very important that these go around the correct way. You can see that it has a notch in the top, and that needs to match up with the notch in the silk screen. Can you see that there at the top of where the TLO74 goes? You could solder those integrated circuits directly into the PCB, but I advise using a socket. In case they get damaged, you can then pull them out and replace them. You'll also need to source some of these male pin headers. These have a pitch, that's the space between the pins, of 2.54 millimeters. They typically come in a long strip like this, and you just break off as many as you want. Just put your thumbnail into the little groove and snap it off like that. Easy. Again, eBay is your friend for these types of things. These normally come in a strip of 40, so just put male pin header 2.54 millimeters 1 by 40. We also need a double row pin header, so that has 2 rows of pins as you'd expect, and this is for our power ribbon cable to go on. These also normally come in strips of 42 by 40, you would search this time. Again, you can just break these off, and you want 2 by 5. The last thing you're going to need is 4 of these 3.5mm jack sockets. These are the ThonkeyCon ones that you can buy from Thonk, no affiliation, and you want to make sure that you've got those hex nuts for them as well. So as well as this bill of materials that's included within the build document itself, there is also a separate bill of materials that you can find in the module documents folder, and this has everything here, as well as some retailer links. Now these are just for examples, they're not necessarily going to be the cheapest or most convenient place for you to buy them, but it gives you a bit more detail. You can look at the data sheets and things to know exactly what you're looking for when you're trying to source all these components. Also, there's a second page where I've broken out the components into the separate boards. There's the back board and the front board, and these components are listed in the order that we are going to be soldering them on in the build document. And there's a couple of little details in these tables just to help you further. You can see again the light grey highlighted components, those are the ones that are included with the partial kit, and the darker grey highlighted values, those are values that we're going to want to use later in the build on the front board. So for example, after you've soldered the 680R resistors into the back board, keep those out to the side because you're going to need those later, and the rest of the stuff you can go ahead and tidy them away so that your desk is clean and tidy, and it'll make the whole experience much more enjoyable for you. Right, let's get going. Let's start with the back board, and if you refer back to the first page, you can see the back board is this one here. It also explains here that this side I'm going to refer to as the top of the board. This is the bottom of the board, and bottom and back are different things. Back board, front board, this is the top of the backboard, this is the bottom of the backboard, okay? And all of the components that we're going to be soldering on have a white silk screen outline that you can see there. You place the components on the side with the silk screen, and then the legs poke through and you solder them onto the other side, okay? We're going to start with the smallest components, that's the diodes. And it'll become clear to you as you do it why we're starting with the smallest ones. D1 is our 1N4148. What you want to do is take it here, bend the legs over, one there, so it looks like that, and then plonk it on in. Remember, of course, that the black stripe has to match the white stripe on the silk screen. Goes in the same way, lies down all the way down onto the silk screen like that, and then you put it on down on the surface, take your soldering iron, and here's where the fun begins. Now if you've not soldered before, then I advise that you go visit the link that I've put down below to the Adafruit Guide to Excellent Soldering. That will show you how to do it and the results that you're looking for. But it's dead easy, let me show you. So make sure that your soldering iron's nice and hot, then you just put it onto the pad and the leg of the component, heat them both up, flow a little bit of solder in, hold it on there for a second longer so the surface tension, you know, does its stuff and sucks it all around how it should do, and then you're done. Pull the iron away and it will make a nice solder joint like that, just slightly raised up around it. Always remember to keep a little bit of solder on the tip of your soldering iron so that it doesn't oxidise. You want to clip off those leads. You can do is if you cut it a little bit further down the cutter, then it won't ping off, it'll actually grab it, well, somewhat, but it will mean that it won't ping off and hit you in the eye. Right, then do those BAT42 diodes. Making sure to remember that that line is round the right way. You can put all of these in at the same time and then solder them all together. Saves you picking up and putting down the soldering iron so much. All the diodes should point the same way. Now onto the resistors. Doesn't matter which way round you solder these in. You just bend the legs over, put them through, solder them on the other side. There we are, that's all of the resistors. Next we're going to do the ceramic capacitors. Next we're going to solder in the 14-pin IC socket. Just like the actual integrated circuits, they also have a notch in the top, and that notch needs to match with the silk screen. It doesn't have to, it won't matter electrically, but it makes it much clearer and easier which way round the actual integrated circuit goes. So make sure that none of the legs are bent, and then you can just put it in to the pads there, push it on down so it's flush with the board, and solder all of those in on the other side. The good thing with hack boards is that I've made the PCBs so that these sockets don't fall out when you turn them around, so you don't have to worry about that. There we are, easy peasy. Now we're going to do the LEDs. These LEDs have to go in the correct way, and on the actual silk screen there is a positive symbol next to the square pad. That's where the positive leg goes in. You can tell the positive leg because it's longer. The negative leg is the short leg, and if you feel on the side of the plasticky bulby bit on the negative side, it will actually have a flattened side as well, so that's another way to tell. But the legs are the easiest way to tell. The long leg is the positive leg. That goes where the positive sign is on the square pad, like so. Push those all the way in so that they lie flat on the board. Those three in, making sure all of the legs are around the right way. Turn it over and then push down as you solder to make sure that the LEDs are flush up against the board, because it will matter in the sensitivity of our control voltage circuit. It's best to just put all 4 electrolytic capacitors in, and then as you turn the board over it will be at the same height and hold itself up. You'll see what I mean. Again, these are polarized, so they need to go in the correct way. The long leg is the positive leg that goes in the pad with the positive symbol next to it. And all of the electrolytic capacitors are facing the same way. Turn them over, push them down so they're flat to the board. They need to be flat, otherwise they may not fit between the gap of our PCBs, and solder them in. So now we're going to turn the board over to the bottom side and solder in the power header. That's this one here, and you just put it in the holes. Because the pads are staggered, it will hold itself in. You turn it over and solder it in. Now we're going to take our TLO74 and insert it into the socket that we've already soldered in. So to do that, you're going to want to bend the legs over a little bit, just because they normally stick out a little bit, and you want to make them so they're sticking straight down so they fit in the socket nicely. All you have to do that is grab it by its ends, put it down on the side on a flat surface, and just lever it over slightly to bend all of those legs in. Do it again on the other side. Then you want to make sure that little indent in the top of the IC is pointing the same way as the indent on our silkscreen and our IC socket, so facing up, and put that in there, making sure that all the legs are seated nicely, none bent under, and apply a bit of even pressure to put it down into the socket. There we are. That is safe as houses. Well, there we are. That's how our backboard is looking at the moment. We're going to put this to the side for a moment just to focus on the front board, and then we'll come back to it. All right. Okay, so again, with the front board, we're going to start with the smallest components, that is the resistors. And if you were paying attention to these tables here, you would have seen that the 680R and the 100K resistors are going to be needed again here, so you'll have them to hand. 3 of each. I recommend doing them separately so that you don't get confused with the values. Accidentally solder the wrong one in the wrong place. That will not be fun. Okay, resistors done. On to the ceramic capacitors again. Boom! There we are. They're done. Looking pretty cool. And now we're on to the 8-pin IC socket. Remember that little divot at the top of the socket matches the silk screen? Right, now we're doing the polyester box capacitors. Doesn't matter which way around these go. Again, I think the best way to do these is put all of them in and then turn the board over and solder them in. Nice, and we got the 1 microfarad electrolytic capacitor to do down here. Remember that the long leg goes to where the positive symbol is. Push it all the way down. Remember, so that you've got the space between the PCB and the panel that's going to be on top of it. Nice, now we're going to do the 4 light dependent resistors, and to do these you need to turn the board over to the bottom side, and they go here, and push them all the way down onto the PCB. When these are soldered in and the whole module is assembled, these are going to be facing the LEDs that we did on the backboard. So there we are, they're all in there. Turn it over and press down to make sure they're all flush with the board and solder them in. So now what we're going to do is flip the board back over and put in the 2 potentiometers. Make sure that the legs are all straight and they're not getting bent. It's all going through the holes. Right, just a bit of manoeuvring to get those side legs in, and that should flatten all the way down securely. There you go, just pop in there and they'll hold themselves in. Make sure that they're pressed all the way down and that all of the legs have gone through the holes. And a little tip, you can use something like a tobacco tin, so you can put it down on it and it will hold itself up. It won't be wobbling round as you try and solder on the back of it. Right, they're soldered in. Now we're going to do the 3 female headers, and they sit on the bottom of the board. You can see the outlines of them here. So you put them on like that, and the pads are staggered, so they'll hold themselves in. Make sure they're pressed all the way down onto the board. Put all of them in, and then you can put it down on the deck and solder them all in at the same time. And these pins, because for some reason, because there's more metal, I guess, and it's sinking away the heat, they need a little bit more heat to get that solder flowing nicely. So just hold your soldering iron on there for a little bit longer than you normally would to heat it up before you introduce the soldering. Or if you've got a variable temperature soldering iron, just turn it up a little bit. Okay, now we're going to affix the standoff to the bottom side of the board. So what you need to do is get the little M2 screw, and that goes through the hole just underneath this pot, this round hole there. And if you just put your thumb on that, turn it over, and then you can thread the standoff onto that and make sure it's nice and tight. There we are. Next we need to pop our TLO72 into its socket. So just the same as before, just bend the legs over a little bit so that they're straight and plop that into the socket. Make sure that that little indent at the top is matching the socket and the silk screen facing upwards. Make sure it's all seated in there right, none of the legs are bent over. Right, and we're going to get ready to put the panel on now. So we just need to put this little slide switch in. Don't solder it yet. Don't solder that yet. And then also put in the jack sockets. You don't need to solder these yet either. Just put them in. They will hold themselves in. There we go. And the little ground leg on the outside, that faces upwards like that. Can you see? On all of them. Cool, so don't need to solder those in just yet. Let's get the panel. We can place the panel over everything, making sure that it's pushed all the way right on down. Get that switch lined up. Cool. And you can put the washers on to the pots and their nuts as well, and the nuts for the jacks. So washers first. There we are. And top tip, you can get yourself some of these hex sockets so you can easily do them up. You don't need to do these up very tight. You can very easily over tighten them. Don't want to do that. There you go. Cool, so they're tightened up and everything's down, and you can just solder on the jack sockets. Don't do the slide switch just yet, and we could use our tin again. Let's put that here, and if you put a bit of electrical tape over the sides, then it won't scratch the panel. Get those jack sockets soldered in. Now what you're going to want to do is push the slide switch so that it's butted right up against the back side of the panel. Then you can put it back down and solder it in. Okay, so our next task is to connect the backboard with the front board and panel. To do that, we're going to need some male headers in the back board. Those normally come in a big long strip like this, so you need to break off 3 lots of 7 pins. So count them across, put your thumb on it, snap them off, and you're going to want to insert them on the top side of the backboard where you can see the silkscreen outline. The pads are staggered so they hold themselves in, and don't solder them in just yet. Right, so they're in there. Next step, then we're going to take the front board, and on the bottom side we're going to put these little baffles in. There's some little slots in between the light dependent resistors. Can you see those? So slot the baffles into those slots there. One in the middle. And one here. There we go. Stand them up straight. Then we can take the backboard, flip it over, and put it all together. Can be a little bit fiddly. Just make sure that the headers are all connected nicely. Push it down, and then these will likely just snap into place. But if they're not, what you can do is take a little screwdriver like this, just poke it through the hole on the back, and just shimmy over the little baffle until it lines up with the hole, and then it will just all slot into place nice. Then we're going to secure it with the screw here through this hole into the standoff that we secured earlier. Once that screws in, it can't fall apart. All good. Right, nearly there. We just got to solder those male headers on. Perfect. Last step, put the knobs on. If you turn them all the way down, then it should go around about there. So then when it's all the way up, it's about the same on the other side. Push them on down. There we are. Well done. You have made a module. Let's test it though to see if it works. Right, here we go. We've got a ribbon cable coming out from our Eurorack case. Going to make sure that the red stripe points down to where the red indicator is on there. Plugs in, and it's all good. Nothing's blown up yet, so that's a good sign. I've got a cable here going off to a speaker. Let's plug that into the square output of our VCO. Square because it's going to have more of an effect when we filter it, just to test that it's working. Yep, so let's plug that to the output of our bandpass filter and then connect that square wave into the input. There we go. Give the knobs a twiddle to make sure they're doing what they should be doing. All good. Position the knobs like this and switch the switch just to make sure it's having the correct effect. And then we can plug the CV input into an LFO or something to check that it's working. Perfect. So if you're not having much luck and something's not working, don't panic. It's normally something really simple that can be fixed very easily, but you just need to calmly go through it methodically and figure it out. So obvious things first: is the ribbon cable connected correctly? Is your case powered on? All the simple stuff like that. Are the cables working? Next is to check the obvious things within the PCBs. So make sure that the circuits that should be round a certain way are round that way. So that's the diodes, the LEDs, the electrolytic capacitors, and that includes also the integrated circuits, the op amps. So make sure that they're in the right way and make sure that none of the legs are bent over. If all of that is still okay, the culprit is most likely going to be a bad solder joint. So just have a good look through all of them, make sure that all of them look good. Refer to that Adafruit Guide to Excellent Soldering to see what you should be looking for. Reflow any of them that look a bit dodgy, just heat them back up, add a little bit of solder if you need to, and that should sort. If you're still having trouble, get in touch with me. I'll be happy to help. There we are. Well done. You've made a module. How cool is that? Awesome. Thank you so much for buying one, and I hope you really enjoyed making it, and I hope you enjoy using it. There's plenty more of these things available on the shop, so go and have a look down there, and I will see you hopefully another time to build another module. Alright.